Okay, so continuing from the previous video, we already have this code and I already add a new code here. Okay, here it is, and this code is to avoid the kernel being too small. So the kernel size is instead adaptive to the image size, but this is just optional and you can use it if you want to replace the previous code here. Okay, next. Here we can see the kernel size that we use, that is 24. And there are 25 regions detected, that is our ROI, from region 0 to region 24. And as you can see, there is still small noises. So in this video, I want to filter these regions so that we can only get the regions that actually contains a paragraph and not small noises. Okay, so contour detection and filtering. After preprocessing, we detect contours in the thresholded image using OpenCV's find contours function. Initially, the contours were processed without filtering, meaning all detected regions were visualized. However, not all contours are useful for OCR. Some may be too small, representing noise or irrelevant details. So to improve the text region detection, we introduce a filtering step based on contour size. So we have this height and width conditions where we only process contours where both the height and width are greater than, for example, 300 pixels. And this removes small noises, artifacts, and non-text regions. And then a rectangle is drawn around the detected region for easy visualization. And by filtering out small contours, we focus only on significant text regions, leading to more accurate OCR results and reducing the chance of misinterpretation caused by irrelevant elements. And this filtering step ensures that OCR process is applied only to meaningful text regions, improving both efficiency and accuracy. Okay. Here we use if statement here to filter out the small noises and only get the contours that contains paragraphs. That is, if the contour have the height and the width above 300, then we can crop the region and draw the rectangles for visualization. And here is the result. We get region 0 and region 8 as the result. Okay. Next, I want to modify the filter further and add a margin. So the new condition ensures that only contours with heights between 300 and 2000 pixels and widths between 300 and 1500 pixels are processed. And this removes excessively small or large regions that may not correspond to text. And we have this margin. A margin of 5 pixels is added around the crop region to include slightly more context, reducing the risk of cutting off important parts of characters. And we draw the rectangle again. And the refined filtering combined with margin adjustment improves text detection accuracy by ensuring that the extracted regions contain complete text without unnecessary elements. And by implementing this updated approach, we enhance the efficiency and effectiveness of the OCR process, leading to better recognition results. Okay, so here I add a margin with 5 pixels, but you can also use this syntax if you want. So that the margin is set to 2% of the contour size, with the minimum is 5 pixels. And then here we filter the contour where if the height is between 300 and 2000 and the width is between the 300 and 1500, then we can crop the region with margin included here. Crop the region with margin. And here's the results. Here's the results. Oh yeah, we also draw rectangles for visualization and also margin included. Okay, so here's the result, and we got here only region 8 as the result. Okay, next is actually optional, but I want to try simple debugging for contour filtering. So in order to ensure that our contour filtering criteria correctly capture relevant text regions while excluding noises, we add a debugging step to examine which contours pass the filtering conditions. So uh, the following code prints out the bounding box coordinates, so x, y, width, and height for each detected contour and checks if it meets the filtering criteria. So here, with bounding box information, each detected contour's coordinates and dimensions are printed to help analyze its position and size in the image, as you can see here. And if a contour meets the size threshold, that is height and width above 300, it is marked as pass. Marked as pass, meaning it qualifies for further OCR processing. And this is useful because it helps verify if the filtering conditions are too strict or too lenient. It also allows fine-tuning of the size thresholds by inspecting which contours are accepted or rejected, and ensures that only meaningful text regions are selected, improving OCR accuracy. So here, the first, so here only contour 0 and contour 8 that are passed by the filter by having the height and width above 300. Okay, like I already explained it before. Next, when the filter is where the height is between 300 and 2000 and the width is between 300 and 1500, only contour 8 that is past the filter. So by using this code, you can adjust the filter so that you can get the right regions more accurately. Okay. Okay, I think that's it for this video. Thank you and see you on the next video. Bye.